Awesome. Thank you very much for being here today, making it to the last talk of the conference, or the closing keynote, which I will now put that in my trip report at work and tell my boss. So thank you for talk today. The talk today is on the future of machine learning and JavaScript. My name is Asim Hussain. You can find me on Twitter as Jawake, not Jawashe, Jawake. I blog about Angular and JavaScript, and very, very soon I'll have more content on machine learning on my website, codecraft.tv, and also soon to be asim.dev. Yes, I bought it. And I am a cloud developer advocate at Microsoft. I'm actually the EMEA lead for cloud developer advocacy at Microsoft. Thank you very much. Recent promotion. Thank you. And we are the Cloud Developer Advocates. So we work on the Azure platform. We are the open source advocates on Azure, which is our cloud platform. If you go to my link there, you can find all of us. You can find all of our contact details on. It's an old one. Shmuel, I don't have you on here. It's an old. Sorry, I apologize. Yeah, so this is us. You can go and find us. We have people who specialize in all different technologies, and we have all of our contact details there. I also work with an Israeli charity called PAL Internship. And what they do is they work with Palestinian recent graduates, and they help them get internships in high-tech Israeli companies. I mentored about 10 of them last year, and I'm very proud to say that this year 17 of all the tech cohort will have a mentor, will be one of the cloud advocates at Microsoft. So if you are or you work at an Israeli high-tech firm and you have openings or availability for an intern, go to that website, come speak to me. I can connect you with Anna, who is the program director. Thank you. I also am an instructor on a platform called Udemy. Does everybody know Udemy? Okay, they recently added in subtitling to the platform, and they correctly transcribed my name to awesome. So my name is Awesome. But like this next slide probably sums up me over the last year. So this is not my slide actually. I've stolen this from my friend Eleanor's slide. Eleanor and I go back a long way, and we're both into machine learning. We're both into JavaScript, and so earlier on last year we decided to start our own meetup group in London called AI JavaScript London, and then we've held quite a few meetups over the course of the year. And what happens is, during the course of these meetups and just afterwards, people will come up to us and give us links to, hey, did you know that this cool JavaScript application uses AI? Oh, this one. And so we thought, okay, fantastic. Let's get all those links together, put it online somewhere, and that's what we did. We made a website called AI.js Rocks. It would have been AI.js Dev, you know, if we'd wait a little bit. But it's AI.js Rocks. And if you go there, it's got a whole collection of JavaScript-powered, AI-powered JavaScript applications, which all represent and show a way of doing AI in JavaScript. What's really cool about it is it's JavaScript, so you can always click on all of them, find out how it works. But then you can also click on, they're all open source, you can click on the source code, figure out how they were built, and hopefully learn a little bit about how to do machine learning and AI. And what today's talk is going to be about is I'm going to talk to you about machine learning and AI in JavaScript by talking my way through 3 different applications that are on the website. Okay? I'm going to explain how those applications were built, and through that whole process today I'm going to teach you a little bit more about machine learning. Until the end you're going to know a hell of a lot about machine learning, I guarantee it. Okay? The first one is the Mojifier. This is my application. I built this one. It's not trademarked. It's just the Mojifier, so it made sense. And what the Mojifier does is it does something amazing. Yeah. So what it does is you can give it a picture with some faces. It then detects the faces in the picture. It then detects the emotion in the face. And then, any guesses? It emojifies it, correct? Excellent. So it finds the correct emoji to match the emotion and places it on the face. Okay, that's exactly what the Emojifier does. In fact, I actually released it as a Slack bot, so you can actually go to themojifier.com, hit add to Slack, and it will be added to any of your Slack workspaces. Right? And it works like this. So, this is my son, by the way, isn't he cute? You add /Mojify, add it in, correct emotion, adds it to the face. It works with multiple faces, so you can get that one and add it in. Here we go. Kind of accurate. And I have managed to answer an age-old question which has plagued people for hundreds of years, and that's the smile. There you go. Thank you, thank you, thank you, thank you, thank you. Elon Musk got nothing on me. So, the Emojifier, what does it do? It's got multiple different moving parts in this application. But I think one of the most interesting parts of what it does is, how does it calculate emotion? Right? That's crazy, right? How does it calculate emotion on a face? But it's actually really simple. It's really simple. It's only got 2 steps. Okay, the first step is detecting facial features. So what are the different, now over all these years, we now are aware of quite a few known facial features which every single face has got, and if we can detect exactly where they are, that's a step 1. And there's loads of different algorithms to make that happen, lots of different computer vision algorithms. It doesn't necessarily need to use machine learning to do it. And that you can find a whole bunch of information out there. There's loads of different JavaScript libraries which can give you the facial features given an image. Okay, that's step 1. You just need the facial features. Okay. Step 2, really simple. You just use a neural network. Okay. Now we all know how to use neural networks in this. Yeah? Oh, shit. Okay. Okay, I'll explain neural networks really briefly, just to the rest of you. So a neural network is based upon real biological concepts. Okay, real biological concepts. So this is a neuron. You have at least one of these in your head. You probably have several million less than you did this time yesterday. You have some dendrites going in, a body, and some axons going out. If enough electricity flows into the dendrites, the body triggers some electricity to go out of the axons. That's it. That's it. If you stick enough of these together, you get a brain. Enough, right? I personally think there's a little bit more to consciousness than just neurons, but to each their own. So if I ask you to code this up using some language, probably JavaScript, you probably all know kind of how to start off with this process. It's just kind of graph theory a little bit. So you have some edges going in, a node, and an edge going out. You would then perhaps feed into the edges some features. Okay, maybe that feature is number of coffee shops in an area and the house price increase per year, which is an actual study done in London. It is directly proportional to coffee shops. And those might be some features you feed into your neuron. And then what you do with the edges, you just have a random number. You randomize it. You give a random number to each edge. You multiply them together, and you add them up, and then you pass that into an activation function. And whatever the activation function returns, you pump that out. That's like the electricity coming in and the electricity going out. That's all it is. Just to explain it a little bit more detail, watch the screen. Boom. This is it. Right? You're just multiplying these two numbers together, adding them up, passing through an activation function, and passing out. That's it. That's machine learning. Right? When I teach machine learning in a workshop, some people halfway through are like, it's just multiplication. And that's all it is. It's just multiplication, right? It's just lots and lots and some addition. But that's mainly a large part of what forms it, right? You can have loads of different activation functions, and the choice of an activation function, it's like you have to understand the data and understand what's going on. But there's loads of different ones. This is a very, very simple one. Anything below 0 is 0. Anything above 0 is 1. And that's the one used there. You join enough of them together. This is what we call a simple feed for, densely connected feed for neural network. So we have one input layer, one output layer, two hidden layers, and it's just the same stuff. Just what I showed you before. Just those neurons connected together. You just create a bunch of nodes, a bunch of edges. You randomize a bunch of numbers to be the weights. Math.random. It is math.random, right? Yeah, math.random. And there you go, there's a neural network. And then what you do, you get your data set, your training data set. That might be a bunch of images that you already know. This is a happy image, this is a sad image. You already know that. You get the facial features, whatever they are. You pump them in as the input nodes. That's what it is. Maybe the XY coordinates of a pupil, or the relative distance between two pupils, something along those lines. You multiply. That's what we're doing here. Remember, multiplication. You just multiply it all together, and you look at what the output is. But because you have, I have a spare slide. Yeah, but so this neural network gave us 3. But we know, because we know that this is a happy face, maybe 10 is happy and 0 is sad. We know that this is 8. We labeled it. A human being said that's actually an 8. So we know that this neural network's wrong. It's wrong by 5. 5. It's wrong by 5. So what we want to do is we need to, that's what we call the loss function. Okay, that's what we know how wrong is this neural network right now. It's probably very, very wrong because it was a random, math.random. So it's probably very, very wrong. And then what we do is something called backpropagation, which, given how wrong it is, we tune these weights that are originally random. We tune them, we adjust them ever so slightly. And we keep on doing that. You pass through the data again and again and again, figures out how wrong it is. Hopefully the wrongness becomes less, and you tune it closer and closer and closer. And all you're doing is tuning those numbers so that eventually the neural network gives you the data that you wanted. And then you can give it a new image, an image it's never ever seen before, and you pumps all this stuff through, and it gives you the value of happiness or sadness or something along those lines. What you can do then is you can just basically save this data and either kind of wrap it in some sort of API, put it on a server, and then make a call, pass an image to it, make a call, and come back. Right? You can do that. They usually can be quite large, and maybe you don't want to run this locally on your computer. It depends, right? You can do that. But these kind of problems are actually really, really common, believe it or not, right? Understand, facial feature recognition, emotional recognition is something that has been solved many, many times before. And then what you do, and what companies like my company does, is we basically make it available via an API. So you have a face API. And I've actually put a request in to have this image changed, because I think she looks very confused. And I don't think we should have an image of somebody looking confused on a marketing material. But anyway, that's what I use for the Emojifier, is the face API. It's everything that we've just described to you has been done, and it's been made available just via an API. You pass an image to the API, and it gives you an array, one for each face it detects. So it gives you the rectangle, because you remember, we need to put an emoji on an image. And it gives you emotions from 0 to 1 for anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. Hands up if you have a beard. I can see you. A couple of us. Yes. You cannot be 100% happy. I've tried. You can only ever get to 99% happiness. Okay? Just warning. And that's it, really. So that's how the key part of how I built the Emojifier. Key takeaway, neural networks, incredibly powerful. When we look at the step jump that's been happening in machine learning over the last 5-6 years, it's been driven a lot by stuff that's going on with neural networks, new algorithms, compute that is working in the space, especially deep neural networks. They're really powerful, but conceptually they're quite simple to understand. In this 5-10 minutes, I've probably explained to you the basics, the very, very basics of a neural network. Okay? They do get much more complicated than that. You're not going to be able to go away now and get a job as a machine learning engineer. Okay? It does get more complicated, but conceptually they're quite easy to understand. All right. App 1 complete. Little drink from this. Okay. TensorFlow, MobileNet, and I'm fine. I was giving a workshop 6 months ago in London, and I was actually wearing this t-shirt which says puppies, Azure, and I'm fine, which actually has a long story behind it. I'm not going to explain it. But I was basically wearing this t-shirt, and then one of the students in the workshop later on made this demo, TensorFlow, MobileNet, and I'm fine, and then sent it out. And I thought it was a pretty cool demo, and I'm going to talk about how it works. So it's just, you can run it, it's in CodePen. Oh, I don't think I provided the link. Maybe it's up there. I'll send the slides out later on. Or you can go to AI.js Rocks and find it. So it's a pretty simple demo. It basically it does a search on puppies on Unsplash, gets an image, and then, oh, you can't really tell, can you? And then tries to guess what's in the image. So then it's going to do, I'm fine, which is platypus, duckbill platypus, Azure, fountain, puppies, come on, okay, dog, terrier, okay, 9%, all right, so it's not the best, okay, it's not the best, but I think the important takeaway from this is the only API request that's being made here is to Unsplash. The detection of what's in the image is all happening on the client side in the browser. Okay. It's using a technology called TensorFlow. Has anybody here heard of TensorFlow? Anybody use TensorFlow? Ooh, a few. There are actually some machine learning engineers here. Excellent. So TensorFlow is a tool that was open sourced by Google in 2015, I think. And it can do a lot of kind of scale that mathematical operations, but it's used a large part. It's used mainly for machine learning. It lets you scale out calculations across GPUs and across hundreds of servers. Yeah, but it's built in C. It's pretty heavyweight. It's kind of something you have to install. Last year, the TensorFlow Dev Summit, they released TensorFlow.js. That's the important one for this conference, is that .js at the end of it. Okay. Now the important thing about TensorFlow.js, when I first heard about this, I thought TensorFlow.js was bindings to TensorFlow. I thought you had to install TensorFlow to use TensorFlow.js. That's not true. TensorFlow.js is a complete rewrite of TensorFlow in JavaScript. Complete rewrite. What does that mean? It means this. It means if all you need to do in order to use TensorFlow in JavaScript is, well, if you're proper, you're this, and if you're still like me, a bit old school, using script tags, you're like that. Okay? But that's all you need to do, is import one JavaScript file, and you can do machine learning. It can do a bunch of different things. It can do what I showed you just before, where I showed you the neural network and the backpropagation and the tuning and all of that stuff. It can do that with an API. But it can also do something else. It can load pre-trained models. It gets interesting. Pre-trained models. That's what we like, right? We just like to import stuff, not write stuff. So that's what we do. So the load pre-trained models. There's an ecosystem forming of like pre-trained models that you can just plug into your applications. And if you go to TF.js models, I think if you search that on Google, you'll find a bunch of them. And that's it. You can train a model, and then once the model is trained, you can save as a JSON file, and then you can use it here. And you can even, if you're using other libraries to do machine learning, you can export them in a format and then convert it into a format which TensorFlow.js likes and uses. Right? One of the models is called MobileNet. And MobileNet is something that has been trained in order to detect 1 of 1,000, it can only detect 1,000 different things in the world. Just 1,000. That's why it was duckbill, platypus, and all this other stuff. It's not very good, right? But it's small enough, mobile, to be able to reasonably be downloaded in the browser, okay? Still very large, but it's a lot less larger than the other ones. But you saw, so that's what he used. He used MobileNet to build this application. Okay, he used MobileNet. You wouldn't really use MobileNet to do real image analysis. It's actually used for something else, like transfer learning and a bunch of other things we don't have time to go into today. Okay, but if you want to do some really more in-depth, meaningful image analysis, the model will be too large to download in your browser, so you have to use something else, such as the Azure Computer Vision API. There she is again. Fantastic. So, does anybody here know Sarah Drasner? Ah, fantastic. So my colleague Sarah built another demo using the computer vision API last year. Her thoughts was, for accessibility, can you automatically create alt text for images in your applications just by sending the image to the computer vision API? One of the things that the API does, it tells you a textual description of what's in the image. Use that as the alt tag. And that's what she did. Again, it's a code pen. You can have a look at it. You can upload whatever image that you want. So she did this one. And the API gives you a whole bunch of information, but it gave you this text at the top. It says a black and white photo of Thomas Edison. The text says, "Hey girl, did we just share electrons because I'm feeling a covalent bond?" I don't know. Is that funny? I don't know. Some people laugh. I don't know. That sounds like it's funny. The thing that I thought was amazing about this is a black and white photo of not just a guy, but Thomas Edison, right? And it also detected the text from the image, right? That's pretty insane, right? It's doing a lot of really intense, cool stuff. But even this API gets it wrong sometimes, as some very helpful people on Twitter. You know Twitter? There's always some very helpful people on Twitter who give some really good advice after you post something on there. So after they put, and hopefully this isn't one of you in the audience, but after she posted this on Twitter, a couple of people came out and had let her know that there were some issues. So this one, it says the image is a star-filled sky. The text says "for" and some Chinese, I think it's Chinese sign. Okay, so it didn't work there. The next one I think could actually be true. The next one, I mean, you don't know, right? I mean, those could be dead, stuffed animals, for all you know. Okay. And I really like the next one. I think the next one we got, I think, 50% correct. Okay. And I didn't do too well at school, so 50% for me is pass. So yeah, so even we get it wrong sometimes. So just to summarize there, and I think if there's one takeaway you should remember from this talk, this is the takeaway. Okay, TensorFlow.js doesn't have any dependencies. If you want to start doing machine learning in JavaScript in the browser, you can just drop that in. The little caveat is the Node.js version does have dependencies, but anyway, the browser-based version doesn't have any dependencies. If you want to get started, when I teach machine learning, I always start off with MobileNet, just loading a model, using it. It's a very, very, very easy way to kind of step into it, but it doesn't really teach you a lot. Right? It's not super useful on its own. So if you want to do something much more complicated, use a computer vision API. We've got one called the Azure Computer Vision API. Did I tell you? I work in the Azure team. Did you guess? Anybody guess? Okay. So, last demo. My favorite demo. Image to image. Okay. Let's watch it. So this is all running in the browser. Okay. So you can draw the outline of a cat, and it will fill in the rest of the cat. Mind-blowing, right? Mind-blowing. And this uses an algorithm called, or technique called pix-to-pix, which is, it's using a neural network, and it's using something called a generative adversarial network. Ah, who said that? You said that. You said that? You get a sticker. Thank you. There you go. A generative adversarial neural network. And these are fascinating. I think it's only been about 2-3 years since the technique has become known. I think they're fascinating. So they work, and this is why I taught you neural networks, so you can get to this point. They have two neural networks that are competing with each other, adversarial. One is called a generator, and one is called a discriminator. Okay? The generator's job is, given some input, let's say the outline, some images which are just the outlines of cats, its job is to generate pictures of cats. But remember, you would have just initialized them with random numbers, so it's not going to do a very good job of generating cat images. It's just going to be noise. Okay? But in any case, you don't care. You take all of your outline of cat images, you generate all your crappy cat images, and you get them all together, and you send them all to the discriminator, which then also has real images of cats. Okay, so as input into the discriminator, it's going to be given a mixture of your generated cats and real cats. And the discriminator's job is to be able to detect the difference. Its job is to say, this is a real cat image, this is a generated cat image. And let's say it got it wrong, because it's going to get it wrong. It's randomized. It's just random numbers. It doesn't know what it's doing. It's probably going to get it wrong. And when it gets it wrong, we have that loss function, and then we do that back propagation, and we retune it, and we make it better and better and better, and it's going to get better and better at discriminating. If it got it right, though, then the generator's not doing a good job, right? And a generator gets tuned until the generator makes better and better. So as the discriminator gets better, the generator gets better, the discriminator gets better, the generator gets better, and we're competing with each other until you reach a point where the discriminator just can't tell anymore between the real cat images and the fake cat images. Okay. And then what you do, this stuff, you wouldn't run this in the browser. This is incredibly compute intensive. You get rid of the discriminator, we don't care about that. You take the generator, you export it into some format that TensorFlow.js likes, which is the TensorFlow.js format. And then you load that into your browser with TF.load model, and you essentially can run this in the browser, and that's exactly what he was doing. I forgot to introduce the guy who made it, Ziad. He's still a student at university. What was I doing at university? Not much. So that's what you can do. So he's managed to get this model small enough. I think the smallest model he's got is still 15 megabytes, still pretty large, but still pretty impressive. He's got it working in the browser. All right. Why? Who cares? It's just some cat images. Who gives a crap about cat images, right? Let's take a look at this. All right. The image on the left is the input. The image on the right is the output. Okay? Input, output. This is computer generated. But this isn't the pix-to-pix algorithm. This is the vid-to-vid algorithm. Yeah? This doesn't work in the browser. Yet. How about this one? One input, multiple outputs. And the input doesn't have to be outlines. The input can be whatever you want it to be. Whatever you want it to be. Okay, so this is another input. It's called a segmented image. So that this is the input, this is the output. The input, like, because it's segmented, you know, kind of like a depth knowledge, you know a little bit more about what's going on in the image. Again, this is the input, this is the output. Okay? She's not dancing. The dancing image is generated. But as I said, the input doesn't even have to be an image. The input can be anything. Anything at all. The input can be text. The input can be text. I don't know if you can read that at the top. That's the input that you entered in, a description of the image that you wanted. The flower has long, thin yellow petals and a lot of yellow anthers in the center. The first image is 600 iterations, and the second image is 1200 iterations. You can't tell with the resolution here, but the second images are very good. Very, very good, very high definition. Then we've got another one here. The bird is white, black, and brown in color with a brown beak. And this one was actually a bit weird, but the rest of them, pretty good representations of images. I think it was 8 years ago, we were unable to tell the difference in an image between a cat and a dog. I think that's where we were 8 years ago. This is where we are now. How long do you think it will take before someone just types in an e-commerce website, blue theme, a contact form, an about page, go? Who cares if it's React or Svelte or, I'm sorry, or Angular? Who cares, right? It's just make me a website. How far? How long away do you think we are from that?
We've got this picture of Wix, Wix API.
Ah, is it Wix? There we go. So just in summary, for this one, so GANs learn to generate new images, and that's what's cool. It's a generative. They generate things. That's what's so cool about them. Previous, like other types of neural network algorithms, they just tell you if something is one thing or the other. GANs generate things. They take a lot of compute to train, but the generated model, the generator, you can optimize it so it can be used inside the browser with TensorFlow.js. If you want to learn a little bit more, I want to get introduced to how to build, if you want to dip your toe a little bit into machine learning, okay, yes, with APIs, but you can go to AKS/Mojifier, and I have instructions. I'll teach you how to build a Slack bot, and you can do all the whole /Mojify and detect emotion and all sort of stuff if you want to figure that out. Thank you very much for your time. Please